This time on Werner's Whirligigs, we're going to be working on making some weights for the adapter for my surface grinder, which holds the wheel in place. We're going to be making some weights just like these. Nothing to it but to do it. So let's get on it. I want you all to remember that I'm just another yokel who is not educated nor a professional in what I'm doing here, and it's possible that if you rely on this video, you, your project, or the both of you might end up as a smoldering hunk of hammered dog shit. Please use common sense, be careful, and always protect your ears, eyes, face, body, and hands when doing this type of work. With that, let's keep on trucking. This video may contain peanuts. Hey everyone, and welcome to Werner's Whirligigs, or welcome back if you've been here before. You might recall that back in November of 24, maybe it was October at this point, I made some 3D printed plastic weights that had some set screws in them as ballast in an attempt to balance my surface grinder adapter and wheel. Unfortunately, I couldn't get enough weight into those weights to balance the wheel, and so it came up a little bit shy, and that was shown in the surface of the metal I was grinding. It just wasn't as good as I had hoped. So today we're going to look at some other solutions besides 3D printed weights, and we'll see what we come up with. As I prepare for my next surface grinder project, I've run into a barrier. I have all these different adapters for holding one of these grinder wheels, but I don't have a functional wheel adapter that I can balance and use on my machine. You might remember this one from a while ago. I 3D printed these weights here, but it turned out that the ballast, which was putting these set screws in here, is not enough weight to balance out the wheel. It's just too heavy on one side, and the weight of these balancing pieces here don't work. So then I bought this thing on eBay. It was cheap. It was like 30 bucks. It's got some balancing weights. It has the right taper in it to go onto my surface grinder, but it's too big. This is the original one from my machine, and here's this other one, and there's just not enough room for this big thing here. So this doesn't work, but for 30 bucks I figured, well, I would just keep it. Then I got a lot of stuff from eBay, a lot meaning one lot of goods, and I got several adapters with nuts. So I got this adapter, and but it doesn't have a balancing rig. And then I got these two other adapters without a nut, and oddly, even though they're the same pitch and diameter, the nut from this one does not fit on any of these. This one is also the same pitch, it's just has a different shape to them. So I don't have a nut for these three. This one actually has balancing ability. It's really cool. You have your adapter here, the plate's going to go on, or the grinding wheel is going to go on here, and you balance it by moving these two rings around. And if you look inside of the rings, you can see that they've been bored out so that this half is going to be heavy, this half is going to be lighter, and you can then, using that, turn these rings so that it balances the wheel. This one has, though, a longer post in it, or shaft, and I need one that's this size for my surface grinder. And the nut doesn't work on here anyway. I could take the cover off and put a nut on here, but the nut doesn't work. But with all of this, I still don't have a working adapter that I can balance. So I think my next step is I'm going to create these wedges in steel and see if I can't make it work like that. What are these little balancing weights? Let me grab one and show it to you real quick. So it's a little wedge-shaped piece of metal, and it has two holes in it. It has one hole where the ball bearing is inserted, and it's full size on this end, and on this other side it's slightly decreased. The hole is slightly decreased so that the ball bearing can't fall out all the way. And then the second hole is a threaded hole where the set screw goes in, and when you tighten the set screw, it pushes on the ball bearing and forces it out. And that is what locks the weight in place when it's sitting down in the adapter. So, now that you've seen that, let's go make some parts. We've got our setup here. The piece of metal, the 12L14 that I'm going to be using to make these parts, is mounted up in the chuck, and now we're going to do some cutting. Okay, to get you oriented, here's the cutting tip, and here's the piece of stock that we're going to be using to make the part. So I'm just going to touch off first and then take a real light pass. Alright, we're going to speed it up a little bit and see how that works out. Alright, that looks a little bit better. Speed it up a little bit. I switched to a different cutting tool now. I was using brazed carbide, and now I'm using a carbide insert on another tool, and I think it cuts a little bit better. So I just got us down to about 3.00 inches, and I need to take this down to 1.93. So now we're just going to start hogging out some metal. And I'm also using this cool mister. Give that a shot. Alright, we need more speed. I'm going to do 60 thousandths. Now we're doing something good. Let's try 80. That's awesome. Try 100 thousandths, tenth of an inch. I feel like that might be just a little bit too much. I'll stick with 80. Now that's a good size for the second piece that I want to make, which is a left threaded nut. So I'm only going to start taking metal now from a width enough to make the wedges, the weight wedges. And why don't I actually, while I'm at it, also take off square up the front. Okay, so now we need to creep up on 1.9. So we'll zero again. Take an 80 thousandth inch cut. Another 80. Alright, we got to 1.925. I'm happy with that. So on to the next step. First thing we're going to do is switch over to a center drill. There we go. So we're going to bring this in and closer and drill. Okay, here we go again. I need to get this hole out to about 1.2 inches. That's a big hole. I don't have a drill that big, so we're going to start with drilling and then we're going to go to a boring bar. I've stepped up to a 3/8 inch drill. I'm going to push it all the way through. Alright, hurrah! We're stepping up to 1/2. 5/8. This is my biggest drill bit, an 11/16. I've switched us over to a boring bar now, so we can get this out. Right now the hole is 11/16, and then I need to bore it out really to 1.2. Wow, I thought I was hearing all those little bits of metal sounded like hail, but it's hailing. Here in Southern California we have hail. Well, let's pick it up again. It's raining pretty hard outside now, but so what? As always, the true test is will the part fit? So remember that this ring is going to turn into some wedge-shaped weights for my adapter. So here's the adapter right here, and it should fit over this now without too much movement. Okay, and it does. There's not a lot of, there's a little bit, but it's pretty good. I wouldn't call it snug, but enough that a little ball bearing can take up the extra space. Cool. All right. And for my next trick, I'm going to part off the piece that I need and leave another piece behind, which will later become a circular nut. Now the real trick is going to be that I'm going to do this without getting my hand in the way, I hope. That seems to have worked. Before we do anything else, I'm just going to clean the other side of the surface here. I could probably take off 50 thousandths and be okay. I left a lot of extra room. So I'm going to turn this on, touch off, and then take away a few cuts just to get rid of this rough surface here on the inside. Okay, so let's bring it up 10 thousandths. I've engaged the power feed. Now this is the side that I parted off, so I'm not surprised that it's not completely flat. I haven't had the best luck parting off and having flat surfaces. It's close. Alright, I'm going to do 10 more just for good luck, whatever that means. So here we are, we've got the ring, and recall that this is the ring that's going to become the wedges. It sits in here like this for now. So I'm just going to blue it up, let it dry, and then I'm going to start scribing some lines in it. Looking at the wedges in this other one that I have, they're about 45 degrees. So I should be able to theoretically make 8 out of this. The kerf from the saw blade, which is I think how I'm going to cut it, it's going to take a little bit of that away, but that's okay. So what we need to do is we need to cut this into wedges. We also need to drill 8 holes around the circle and then thread them. And then we're going to drill 8 more holes in from the side, and that's where the ball bearing is going to go. My DRO is set up now so that I can drill 16 holes in a circle around the diameter 1.66 inches. So imagine that this is the ring here going around, and I need 16 marks, not holes, but just marks going around. 8 of them will be where I'm going to use my bandsaw to cut the ring into wedges, and every other one will be to put in a set screw. So I'm going to do the first one and allow you to follow along on the screen. It tells me where to go next. So bring it over here. Now I'm going to drill a hole. You can just hear it. Just a little teeny mark. Alright, then we're going to go to the next hole. So then I use the DRO, go over there. That's where the second hole is going to go. Turn it on. And now I'll let you follow along as I do the other 14. All right, now we're going to drill out some holes for the set screws.
Their engine problems and become competitive. So I can tremendous.
Well, you believe that at my rate, I have to tell you, I threw in that well because he did say, didn't he, but this did when he got out of the college. Viper, and the Audi takes the lead again in the number 77 car. While the he had absolutely no idea what the cloud cover was. They are reliable, they are fast, and they just run like trains the whole time.
Fabulous engine, which John Palmer always prepared fabulously, absolutely without flaw, and that's given them that bedrock.
Now that we've drilled those holes, we're going to power tap them with a 3/16 24 tap. I'm using my Clausing drill press, and it has a VFD, variable frequency drive, on it, as well as infinite speed control. So when I turn the speed all the way down on the VFD and on the drill, it gets to about 60 RPM, or 1 revolution per second. This is mounted on an XY table, so I can move around the part to the appropriate location. And to be honest, I'm just going to eyeball it. I'm going to eyeball if the tap is in the right location to go into the hole. So let's give it a shot here. I did indeed break off the tap inside of the hole here, and I tried to get it out by drilling it out, and I just could not even penetrate the material. So anyway, so we still have 6 good holes. 1, 2, 3, 4, 5, 6. This one I drilled out too large when I was experimenting, and so, but we're going to finish up 1, 2, 3, 4, 5, 6. And the other 2 are going to the scrap pile. So now that we've finished up the holes going through this face here, I need to devise a way to put holes radially here, 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 etc. So what I'm going to do is make an arbor out of this piece of metal here, and then I'll put that in my 5C collet indexer and put it up on the mill again and drill those holes through. And if it doesn't make sense, don't worry, it will. I almost started the first cut without you. Well, I kind of did, but didn't get too far. I set up an automatic stop, so let's see how that works. Doesn't like that either. Maybe we just need to hog some metal. do 70 thousandths. This is going to feel familiar. God, this stuff makes a mess. I think I have everything tuned up to turn some threads, so let's give it a shot. I'm going to do just a little bit more. So now I can take this out and transfer it over to the mill again. I've moved over to my vertical mill now, and you can see I have this Hardinge HV4N indexer set up on the table, and I've taken the 5C collet that was in the lathe and I've transferred it over to the indexer. The indexer is also aligned parallel to the table itself and perpendicular to this axis. And quickly, if you're not familiar with an indexer, it holds your part with a 5C collet here at the end and can rotate 360 degrees. And there's a plate here that has 24 holes, and you can, whether the screw in each of those holes is in or out, determines whether it will stop when it reaches that point in the rotation. So I've set it up so that 8 out of those 24 holes have the screw in the place to stop. And that means every 45 degrees, or 1/8 of a turn, this will stop. And that will help me precisely line up the hole with the ones on the side of this piece. So What we now do is we take this piece that we made over there, this arbor, that has our part in it and a nut on the end, and we can transfer it over here, and with some degree of precision we should be in a very similar setup. So let me find, I made some alignment marks on the piece. There they are. I've zoomed in on the part. It's still difficult to see, but you see here there's some lines going across right here this way. That represents the middle point of one of the holes. So we need to make sure that the part here where the drill comes down is perpendicular. So let's start with that. How we do that is we bring the point down. The idea is that the ruler will be perfectly horizontal when the tip of the drill is located perpendicular to the part. So we're pretty close here, but let me just take it out of horizontal so you can see what I mean. See, as I push it back, it wants to fall over back towards the back end. And as I'm now moving the part towards the back of the table and pulling the drill bit forward, this thing rocks the other way. Now that the drill bit is perpendicular to the highest point on this ring, we now just need to line up our mark. Again, I know it's hard to see, but it's right here. We need to line that mark up with the tip of the bit, and then we lock it in the indexer, and we now are ready to drill. We're going to drill with the center drill just to make a mark. Let's get to it. That first mark of shame wasn't enough, I guess. Okay, we're coming back around now. Oh, perfect. We're just about ready to start drilling these radial holes. So how we're going to do this, we need the hole to be the same diameter all the way until just before it reaches the inside face, and that's so that the ball bearing doesn't fall out of that side of the hole. So first, I'm going to go through and in each of the holes use a .138 drill bit, which is the smaller of the two, and I'm going to drill it all the way through. Then I'm going to come back and follow up with a slightly larger bit. It's .1575, I think. And but I'm not going to go all the way down to the bottom. Actually, just so we know how deep we're going, I'm just going to zero the bit on my DRO by moving it down until it stops here. So that's the 0 point when the bit is touching the top of the metal. Okay, we'll bring it back and line it up with the hole, which will be the next click in the indexer. There we go. And now I'm just going to turn on the drill, and I'm going to drill through the piece. now we're ready to go ahead and drill the larger hole. So I'm making a hole for a 4mm BB, which is 0.157 inches. So I'm going with a number 20 drill, which is 0.161. Through practice, I've determined that I need to go about 15 thousandths further than the width of the piece of metal, assuming that the tip of the drill starts at the top surface of the piece. The trick is to not go too far and blow out the end of the hole so the BB will fall out in the future. Well, here's where we are after that last step, and I like the way things turned out so far. You know, we have these holes here on the side that were drilled out to 0.161, and the BB fits in there very nicely. At the same time, the BBs aren't falling out the other side, but they're sticking out just enough that there will be some friction between them and the adapter, and so they're going to stay in place. So if we back out the set screw, then you can push those BBs in right now, but once you tighten it back in, that BB is going to come out and keep things in place. And the last thing to notice is these small holes here. This is where I'm going to cut apart this piece here, and I don't have a better way to do it, so I'm just going to use my bandsaw and hope for the best. On top of losing the sound for the bandsaw footage, the video is awful. I just wasn't thinking, and my hands were pretty much in front of the camera the whole time, so you can't hardly see anything. So we'll just skip over that and get to the good stuff. Here's the finished product, along with the plastic ones I 3D printed back last year. So, bringing it up closer to the camera. Got our wedge shape, got our set screw. Most importantly, the ball bearing comes through. So now, the big test. How much do they weigh, and will they help me balance my lopsided grinding wheel? First of all, let's weigh 3 of the balance weights from the last round. These are the plastic ones with the ballast, set screw ballast. So 3 of them weigh about 9 grams. And how about 3 of these guys? All right, 18 grams. So 100% increase in weight. Let me just check the other 3. Again, 18 grams. So we've increased the weight by 100%. Let's see if that's enough to balance the wheel. I've got the wheel on an adapter with the balancing weights here, on the shop-made arbor from last year, on the shop-made balancing stand. So just give it a little turn here and see what happens. And before, the red line that's sticking up from the label was the light point, or near the light point of the wheel. And the way we've placed the weights around the adapter right now, they shouldn't really have any impact on balancing the wheel, since they're somewhat equally placed from each other. And we see again that this is still the case. This is still the light side of the wheel, although obviously it's here right now. So let's just group them all three of them together up near the lightest point, and let's see if we can make that the heaviest point. Because if we can, that means we have enough weight on here to overcome the weight of the wheel. Okay, so this is where we started. Oh, that's beautiful. Isn't interesting? Just the 9 grams difference in weight, what is enough to offset the imbalance in the wheel. All right, so then now let's try to make this balanced. Okay, it's still a little bit off balance. The heavy point is here, so we need to bring some more weight towards this point here. I'll just move this one in a little bit. It seems like it still wants to go a little bit. Okay, seems like we still need to move some weight towards the known light point on the wheel. Let's try that. That might be looking better. I think we might have it. I'm going to just try another balancing stand that I made. I'm giving to a friend. Let's just see if this one tells us any kind of a different story. I think we're successful. That's really exciting. We're going to be drawing this video to a close, and that means shutting down before we actually get to test this on the surface grinder. But time is of the essence, and I need to get this video up and out there. So we'll see the results very soon. Thank you for coming by. I really do appreciate it. If you enjoyed the video, I always appreciate a thumbs up. Feel free to subscribe. I try to put out videos on the 1st, 11th, and the 21st. In March, I missed a video because I went down to Sebring, Florida for the 12 Hours race. And I was gone for 11 days, so I just didn't have time to make a video. But that's okay. I've still got content coming. One final thought. Making these weights, there were a lot of different processes that went into that. I counted the other day, and I think it's like 10 or 11. And then, but we have this other type over here, this one here, that has the 2 weights on top. And these are much simpler to make. You have a ring, so that, let's call that 1, 2, 3, 4, and then 5, 6, and then 7. I don't know, it just feels like it's a simpler process to make something like this than it is to make those little wedges. So I may try that out pretty soon, but I need to get working on these vices for my friend Rodolfo and get them out of here. Gosh, he's been waiting for a half a year, and I feel badly. But that's going to be it. I hope to see you next time. So long for now.